Hello, let's start section 1.3. Section 1.3, we are discussing here models and applications. Models and applications in a simple language means word problems. Word problems, but word problems for linear equations. In your homework, I made your homework very simple. I just brought the part that you are solving an equation or a formula for a specified variable, which I will discuss it today. But I will talk a little bit about the word problems, how you make a word problems or how you can solve a word problems. Also, the other part is word problems, or I can say geometric problems. We will discuss those. And at the end, we will discuss solving an equation or solving a formula for a specified variables. Of course, in your test, whatever the homework is, that one will be involved. I'm not focusing too much on word problems because basically you are on the third day of the class, correct? This is the third lecture of your class, and I don't want to give you immediately word problems. I know many students, they have problem with word problems. I want to a little bit wait, then start with the word problems. But anyway, I'll explain to you today the simple form of word problems, which is not that difficult, correct? When you are dealing with the word problem, or in general, which we call it an application, there are few steps that you have to focus on. Step one, when they give you a word problem, read and read and maybe read it for the third time also. Read it really carefully. Do not read fast, correct? Because you want to translate the word to algebra, correct? Later, I'll show you the process. Number two, or step two, write an equation. Sometimes even it's good to draw a diagram, correct? Draw diagram if it's possible. Draw the shape, because when we discuss the geometric part here, you need to, if it's possible, it's better even to draw the shape, correct? Step three. And step three, solve. Solve your equation that you created. And step four, translate back to Word. Translate back to what? To Word. To show this four step as a process, when you are dealing with the word problem, they give you a problem in an English word, correct? You translate the word to algebra or to math. Then you solve. Then, after you solve, you have to translate it back to what? To Word. This is the steps that you have to know in Any word problems, we follow these steps, even in the stats. I know many professors, they just give you a calculator, they teach you, okay, solve this, find this, and calculator, and you are using TI-84, plug in the numbers, even the formulas, they're ready for you. Push the button, it gives you a number, and you put the number. But what that number means, that's important. Because in stats, it's not just all about numbers. Stats is about giving recommendation, writing something, what will happen, what happened. We discuss those kind of issues. And if you are good in algebra, solving word problems, of course, when you go to stats class, you will not have any problem, correct? There is no formula here that I can teach you, okay, do it this way. Let's just start with the example. I will show you how you can create a example, sorry, an equation and how you solve, correct? I'm reading the example from the book. There is no time, that much time to write, and it's not necessary to rewrite the problem on the screen here for you. This example is on page 125, section 1.3 of your book. The average yearly salary of a man with bachelor's degree exceeds that of a man with an associate degree by $25,000. Correct? If a man has a bachelor degree or a person have an associate degree, here you have bachelor's, BA, correct? The salary of a man who has a bachelor's degree per year, the annual salary, is $25,000 more than the man who has only associate degree. Look, a man has associate degree. How much is his salary? Do we know? Do they mention that in the first part of the problem, any salary for associate degree? No. When something is unknown for us in algebra, we usually choose a variable for it, correct? If I choose or name the salary of a person which has associate degree X, then a person who has a bachelor's degree, his salary will be X plus 25 because $25,000 more than his salary, correct? Next part of the problem, the average yearly salary of a man with master's degree exceeds that a man with an associate degree by $45,000. Okay, if you do a master's, your salary will be $45,000 more than a man that has only associate degree. Maybe you see I'm writing first 45, then I put a plus sign here, then I put an X. Usually for the word more than, less than, more than and less than, you write from right to left. More than a number, it means your number plus something. Less than a number, it means X minus something, correct? Now, last part of the problem. Three men with each of these degrees earns 214,000. Find the average salary of a man with each of these levels. Correct? The total salary of them. The total salary of these three people. is $214,000. Find the salary of each one of them. Basically, you see what I created in the top. If I put all of them together, I made an equation. Total salary. What does it mean? It means add all of these salaries. It means add X with X plus 25 and add this one with X plus 45. How much is the total? Remember, is means when you are writing an equation means equal sign. Is $214,000. You see, you created really a simple linear equation. Remove the parentheses. X plus 25 plus X plus 45 equal 2014. X plus X gives you 3X. And 25 plus 45 gives you 70, right? Equals 214. Subtract 70 from both sides. Then 3X equals 4 minus 0 gives you 4. 11 minus 7 gives you 444. Divide both sides by 3. These two cancels out. Then X equals, can we divide? 18. Yes, we can divide. I'm sure you know how to know if you can divide this number by 3. If you are not, just use the calculator, correct? I divide this by 3, it gives me how much? 48. Correct? Now, I'm not done yet. I only find the value of X, correct? They are asking you to talk about the salary of each person. Now, your associate degree, I named it X. And how much is X? X is 48. Because it's in thousands, it's yearly, it means a man with associate degree can make maximum maybe around 88,000. In this example, 88,000, $48,000 in a year. A man with bachelor's degree, it was X plus 25, right? It means plug in your X here, it will be 48 plus 25, which gives you 73, right? A man with a bachelor's degree can make $73,000 in a year. But a man who has a master's degree, it was X plus 45, right? It means 48 plus 45, which gives you $93,000 per year. After you solved, you see, first it was Word. I translated to Algebra. Then I solved. Then I'm back translating it to a Word, right? Associate degree, $48,000. Bachelor's, $73,000. Master's, $93,000. How to check if you did correct or wrong? Add these three numbers together. 48 plus 73 plus 93. And if you see, at the end, it gives you $214,000, correct? Which was the total that they give you in the problem. This is how you make a word problem. Correct? Sometimes they give you the problems. One number is 25 more than the second number. The third number is the twice of the second number. If their total is this much, find the numbers, correct? These kind of problems. The setup is the same. The first one is unknown, make X. Based on that, set the others, correct? This part I just explained to you. I'm not focusing. That's why I only do one examples, but there are 3 or 4 examples in your book that you can focus on it. The second part of this lecture is sometimes you are dealing with geometric shapes. Even in our normal life, we use that a lot to find, for example, the length or the width of something. We use it a lot. Let's focus a little bit on those kind of problems, correct? Before focusing on those problems, there is a good table on page 132, same section, section 1.3, that gives you some formulas for some shapes in geometry, correct? For example, if you have a rectangle like this, with the length and with the width, the formula for the area is L times W, correct? If you want to find the perimeter of this rectangle, your formula is 2L plus 2W, correct? I'll stop the lecture just for a minute. I'll be back. Okay, I'm sorry, I stopped the lecture for a minute. There was a call for me. This is, for example, the formula for how to find the area of a rectangle or how to find the perimeter of a rectangle. Same way, in the same page, you have formula for a circle. You have a formula for a triangle, or you have a formula for a trapezoid, correct? Different kind of shapes also on that page, how to find the volume of something. If it's a cube, if it's a rectangular shape, or if it's a cylinder, or even if it's a sphere, correct? How to find the formulas are all on page 132, section 1.3, correct? Or even in my slides, correct, that I uploaded in your Canvas, you can find those formulas. Now, in these problems, for example, let me start with a rectangular shape. How you solve a word problem, I'll explain it to you. For example, you have a backyard that it's a rectangular shape, correct? And you have some fence ready at home. extra. You use that sometimes, and you have some fence and you wanna just put some fence around your yard, backyard at home. For example, let's say you have 1,000 feet of fence at home. Now, how much of this sides, or how much will be the length, or how much will be the width of your backyard, and you can use 1,000 feet of uh, fence to do the fencing in your backyard, correct? To solve this problem, you need to use the perimeter formula of your rectangle, correct? Because perimeter equals 2L plus 2W. If you put 2L plus 2W equal 1,000 feet, you can easily find how much is which side, correct? I'll not solve this. I'll just explain where you use it. I'll just copy an example from your book and I'll solve that example for you. Example 6, page 132, finding the dimensions of an American football field. Everyone knows what is an American football field. That's the shape of an American football field. Let's read the problem. The length of an American football field is 200 feet more than the width, correct? The length is 200 feet more than the width, but they don't give you how much is the width. If you don't know how much, choose a variable for your width. How much is the width? X. Now, how much is the length? You are writing this side in terms of this side. If you use here X, use here also X. Correct? Now, second part of the problem. If the perimeter of the field is 1,040 feet, if my perimeter, which is around this field, 1,040 feet, find the length and the width of the football field. It means if I want to create here a formula based on the rectangular or the rectangle perimeter formula, P is equal to L plus 2W. It means if this side is X, this side is also X. If this side is X plus 200, definitely this side is also X plus 200, right? Now, if I add all these four sides, it should give me my perimeter, which is 1,040 feet. Then let's write, or you can even plug in this formula. How much is perimeter? 1,040 equals 2 times length. How much is length? X plus 200. Plus, how much is the width? 2 times X. Here, distribute the X. Instead of adding all of them, I just use the formula, right? 1,040 equals 2X plus 400 plus 2X. Of course, we combine like terms. 1,040 equals 4X plus 400. Subtract 400 from both sides. Then 4X equals 1040 minus 400 gives you 640. Now divide both sides by 4. X equals 160 because we are using feet, 160 feet. It means you see here, your width is 160 feet. How much is the length? X plus 200 is the length, right? It means 160 plus 200, which gives you 360 feet. Correct? Using shapes, you can solve a word problem. These were kind of extra lectures. I cannot say extra, at least with the design of your um, test or my program or even your homework, that part was extra. I just explained to you. The main point that you have homework on it, and I will take a test also from that. It means a problem will come from that section or that part to your test is solving an equation or solving a formula. Solving a formula for a variable. Correct? This topic, believe me, it's really, really important topic, not only in math. If you take a physics class, you always deal with formulas. If you take a biology class, there are formulas there. If you take a chemistry class, there are formulas in chemistry. If you take an economic class, like if you're a major of finance or if you're a major of business, there are formulas in business, correct? It means formulas are everywhere. Solving a problem is not maybe difficult for a student. Solving a formula with a different variable for a specified variable, always difficult for the students who are attending the physics class, chemistry class, or a biology class. Let me explain here for you how you can solve a formula for a specified variable. Look, let's consider a very simple formula. Distance equals v times t. Velocity times time gives you always distance, correct? Even maybe you saw this formula in grade 6, 7, 8 of a school, d equal v times t. First, before solving this formula for a specified variable, let me explain something for you. When you are writing a formula, do you see the equation sign here? Here, equation sign. Equation sign give me an idea that any formula, basically a formula is an equation, correct? If a formula is an equation, it means I can apply the properties of the equation, which I discussed it, I think in section 1.1, I can apply, right? The addition property, the subtraction property, the multiplication property, the division property of an equation I can apply on a formula. Then, if I know this much, solving a formula for a specified variable is not difficult. For example, in this formula, if I ask you, okay, I give you a general formula, distance equals velocity times time, correct? If I ask you what is the formula for velocity, you should be able to solve this equation for v, correct? I will rewrite this equation here. D equals v times t. If I ask you to solve this formula for v, it means isolate v and move the other variables to the other side. Let me show you in a numeric example. Compare this formula with this example. 6 equals 2 times x. Here, your 2 is t, 6 is d, and x is v. If I ask you here, 6 equal to x, how much is x? Definitely you will tell me, okay, divide both sides by 2. Very fast. X is equal 3, right? Basically, you follow the same rule here. If someone is asking you, solve it for v, okay, to solve for v, I have to isolate v and get rid of t. How? I'm dividing both sides of my equation or formula by t. These two cancels out, then v equals d over t, final answer. Here, velocity equals distance divided by time. How much time you need to drive from one point to another point. If you divide that distance by your time, it gives you the velocity. Correct? Even you can solve this problem for t. Correct? I'll do different examples for you. Look at this. The perimeter of a rectangle, P equals 2L plus 2W. If someone asking you solve this formula for L, what will you do? Let me change the color of P also back to black. P equals 2L plus 2W. Solve for L. Solve for L, if you are a little bit slow, first change this color to red. It means isolate L. I change it to the color because I don't want to touch this. This L should be alone on this side. Everything else should be moved on the other side. I don't want to make it complicated for you. Don't take it that way. But look at this problem. If you have 2x plus 4 equals 8, how do you solve this simple equation for x? Your first thing is to subtract 4, correct? Compare, they're the same thing, you see. My first step here should be to subtract 2w from both sides, to get rid of 2w from that side. These two cancels out here, these two 4s cancels out. Then 2x equals 8, right? Subtract 4, sorry, not 8, 4, right? Wrong math. 8 minus 4 gives you 4. With the numbers, it's easy. You can subtract from 8, 4, and you know the result, that's 4. But here, look here, P minus 2W. You cannot subtract W from P. They are not same variables. What you can do, you can write it this way. P minus 2W equals what? 2L. That's it. The only difference of solving an equation with or solving a formula for a specified variable is that here you cannot simplify. You have to rewrite, correct? With the numbers, yes, you can simplify. But with the variables, you have to keep them. You see, it's P minus 2W, and I write P minus 2W. Now, solving for L, it means divide both sides by 2. Then here you go. L equals P minus 2W over 2. Your final answer. You solve this equation for L. Same way you can solve this equation for W. Correct? Let me show you another one. For example, I'll take this one also from your book. A equals P plus P or T. P or T means P times R times T, right? They are asking you in this problem, solve it for P. Basically, this is the second or the first example in this lecture, the second example in this lecture, because you did it before in Math 35 or intermediate algebra. They, in your book, immediately they jump to a kind of complicated one. Solving this equation for P, you see you have here P, you have here in this term P, and this term P. You cannot immediately subtract PRT from both sides. No. What is the first step? Let's say if I'm dealing with something like this. 6 equals, of course, here 3xy plus 3x. If I ask you to solve this problem, what will you do? The first thing that you do, definitely you will factor x, correct? I'm receiving a lot of phone calls today. Okay, I'm back. Whatever I'm trying to explain here, if you have a shared variable in two terms, you have to first factor it. Look, and I teach you how to factor, right? X is common in both. Take x as a common. Here, 3y plus 3, right? What we do in these types of the problem, I have p here, I have p here. I'll take p as a common. Then a equals p, parentheses, p divided by p gives you 1, plus p RT divided by p gives you only RT. Then a equals, sorry, we're done with that one. Now, solving for p. If I solve for p, I have to divide both sides by what? By 1 plus RT. 1 plus RT. These two cancels out. Then p equals a over 1 plus RT, final answer. One more example. 1 over f equals 1 over f1 plus 1 over f2. Solve, for example, this equation for f2. Basically, it's actually one of the physics formula in different notation, correct? First thing to know, f and f1 and f2, they are not the same. Oh, it's f, let's take one of them. No, f is something else, f1 is something else, f2 is something else. They are different variables. They are not the same. Remember the day that I explained for you how to solve an equation involving fractions, I told you find the common denominator or LCD between the fractions. if I want to find here LCD, my LCD will be F1, F2, correct? That's my LCD. Now, if I want to solve this, I will multiply here F1, F2. I will multiply here F1, F2, and I will multiply here F1, F2. Here F cancels out with F. Here F1 cancels out with F1. Here F2 cancels out with F2. And I'll end up with a very simple equation, which is F1, F2 equals F2 plus F1. Now I'm solving for F2. It means, you see, I have F2 in this side of the equation. I have F2 on this side of the equation. First, I have to move F2s to one side. It means I will subtract F2 from both sides. F2. Your left side will be F1, F2 minus F2 equals F1. Now, solving for F2, you see you have F2 in this term, you have F2 in this term. You can take it common. Then F2, parentheses, F1, F2 divided by F2 gives you F1. Minus F2 divided by F2 gives you only F equals F1. Solving for F2, last step, I will divide both sides by F1 minus F1 minus F. These two cancels out. Final answer, F2 equals F1 over F1 minus F. I solved my formula for F2. You can solve this formula for F1. Correct? This was all about the applications and models for linear equation. Our main focus is on the last part of this lecture, which is formulas, correct? And you have, I assigned you a few problems from this section as a homework. I think I assigned from 41 to something. It's all formulas that you can solve. I'll stop the lecture here and see you next time in section 1.4.